It's a true honor to be here with you today, especially among the esteemed speakers that we've already heard. And I don't know if you saw in your program that Dr. Ferrucci is getting an award tomorrow. So when you see him, give him a congratulations. So I've been tasked with the difficult title of B vitamins and homocysteine and cognitive function. Here is my disclaimer. I work for the National Institutes of Health, so what I say is my own thoughts and not that of any government entity, and I have no conflicts of interest to disclose. So cognitive function has a simple definition that is a set of mental processes crucial for activities of daily living. But cognitive function is not simple in any other way. You can see the multiple domains of cognition that I've presented here. And with aging, these different domains change at different rates. Some are maintained throughout adulthood, like vocabulary, whereas others decrease over time. So cognitive function, much like Isabella Rossellini and my mother are the same exact age, and they look nothing alike. Cognitive function is so highly variable, and that's why studying it is very difficult. There are disorders of cognition, starting with cognitive impairment, which can range from mild, simple forgetfulness that doesn't really impact activities of daily living, to severe cognitive impairment, which does impact daily living. Dementia, there are several kinds. I've listed the most common here. Alzheimer's represents about 60 to 80% of cases. And there are 5 million Americans right now with Alzheimer's disease, comparing that to 15 million with mild cognitive impairment. So you can get a sense of the numbers. And from the data we've seen today with the demographic shift in older adults, certainly this is an area that is of public health concern. It's very difficult to measure cognitive function because it is complex and also because of the variability. Nevertheless, the tools that are used are generally broken into two categories. One, global measures, and you're probably familiar with these, the mini mental state exam, and TICS, which is a modification of the MMSE. These measure global cognitive function. There are a multitude of tests that then measured specific domains that I alluded to on that first slide. And researchers also use composite scores from these domain specifics to get a much bigger picture. So some of the types of questions on these, I thought I would just present these to you as sort of a human interest. Remember these three words: ball, tree, flag. Spell the word world backwards. I would list 7 numbers and then ask you to repeat them back to me. List as many words as you can with a letter Q in 30 seconds. Things like this where you can see that they're difficult, especially if you're trying really hard and you're stressed out about doing well. That makes measuring cognition really difficult. So as we've been talking about all day, age is the most direct factor related to cognitive decline. Aging is also associated with other chronic diseases like stroke and cardiovascular disease that are known to influence cognitive function. There are also structural changes in certain brain regions with aging, and there's a decline in episodic memory starting in mid to late 40s. And this data is from both humans and non-human primates. And why I mention that is because this is a time of age in our lives where we're assuming more responsibilities in our jobs, we have children, so we're in general much more stressed out. So it was originally thought that this decline in memory was perhaps a result of stress and anxiety, but in non-human primates, we see the same thing. So it is likely due to these structural changes in the brain. Educational attainment is highly tied to cognitive decline, especially for males. Females are more likely to have Alzheimer's disease, but males are more likely to have the vascular types of dementia. And genetics and family history. I'm sure you're all familiar with the ApoE gene that comes in 2, 3, and 4, with 4 being the most widely known risk factor. Having one copy of this increases the risk of Alzheimer's by 4-fold, having 2 copies by 10-fold. But ApoE is neither sufficient nor necessary to cause Alzheimer's disease. There are 3 large twin studies that suggest about 30 to 60% of our memory is heritable. So if you're a glass half full kind of person, that means we have some numbers to play with, but if you're a glass half empty, you might take that as a negative percentage. What I think is more interesting are the modifiable risk factors for cognitive decline, and this is where we can have an impact. Some of the chronic diseases I listed in non-modifiable and modifiable because things like hypertension, obesity, risk of diabetes, these are to some extent modifiable. We touched a little bit about physical activity, and physical activity works through reducing these risk factors like hypertension and weight, but also has its own independent role in increasing blood flow to the brain, and may also work through reducing depression, which is highly tied to cognitive decline. So there are a number of dietary factors that have been investigated with regards to cognitive decline, and I didn't think it was possible for me to do due diligence to all of these in one talk, so I'm going to focus primarily today on homocysteine and the B vitamins. And we've talked a little bit about this. This is the evidence pyramid, so I'm going to present some data from systematic reviews as well as individual randomized clinical trials. There is a sense for some in the cognition field that systematic reviews are not a good representation in cognitive function because of the variability, the differences in the population groups, the doses and durations of the supplementation trials that don't easily lend themselves to systematic reviews, but nevertheless, I will present you all the data and you can make some decisions for yourself. So there is an interplay with folate, B12, and homocysteine. And folate is involved with methylation pathways that influence genetic mechanisms, gene expression, and plasticity and stability of neuronal circuits. So certainly there's a good biological plausibility for why low folate could cause cognitive problems. Similarly, it's widely known that vitamin B12 deficiency causes irreversible neurological impairment and also leads to an accumulation of methylmalonic acid, decreasing malonyl-CoA, leading to an accumulation of branched-chain fatty acids in the membranes of neural tissues. So this is the biological plausibility for vitamin B12, and both low folate and or low B12 cause elevations in homocysteine, which is thought to be neurotoxic. So this is a review that came out this year, and it doesn't focus specifically on homocysteine. It looks at a number of risk factors. So if you're looking for a good review on this topic, I would point you in this direction. But elevated homocysteine in a number of prospective studies, I think there were 26 studies, is associated with a host of cognitive issues. And I have them all listed here. I'm not going to read them to you, but take my word for it. There's a meta-analysis that also came out this year looking at the available data from randomized clinical trials. And you can see here the title and the push, I guess, for AJCN to have the very declarative title. So this is a trial of 11 trials, 22,000 individuals, looking at the effects of reducing homocysteine concentrations. So for 4 of the 11 trials, they had domain-specific measurements. And you can see them listed here: memory, speed, executive function, and then a global composite. And so if this crosses 0, there's no significant change. And so without looking too closely on this, the meta-analysis indicates that there's absolutely no effect of lowering homocysteine for any of these domain-specific types of cognitive function. The other 7 of the 11 trials had global measures through the MMSE or the TICs that I mentioned, and similarly, absolutely nothing positive to be gained from B vitamin supplementation. This was the take-home message that had no significant effect on individual cognitive domains, global cognitive function, or cognitive aging. But as I alluded to earlier when I presented the evidence pyramid, there's a number of criticisms with this type of meta-analysis. There was significant heterogeneity with the trials. They were different in age. They were different in the types of supplements they used. All of them used folic acid, but not all of them used B12. Some used B12 and B6. So we're really comparing apples and oranges to a certain extent and coming up with a fruit salad that may or may not be very interpretable. And a lot of the trials were for secondary prevention of cardiovascular disease. And as we talked about earlier, cardiovascular disease, you are already at an increased risk for cognitive decline. So the external validity of this meta-analysis has been questioned. And only three trials only had a measure of cognition at the end. So they weren't able to assess change before. They just looked at post-intervention. So what I'd like to present to you in the next couple of minutes is the VITACOG trial. And this is from David Smith's group in Oxford. And they are major critics of the meta-analysis, mainly because they think that those were trials that were conducted in cognitively normal adults, and so why would we expect short-term supplementation of vitamins to change their trajectory? So they were interested in looking at individuals who had mild cognitive impairment, because that represents a large proportion of the population. People with mild cognitive impairment convert to Alzheimer's dementia's much faster rate than people without mild cognitive impairment. So they thought this was perhaps a group where intervention might be effective. It's a small clinical trial of 270 community-dwelling adults with mild cognitive impairment who were given 3 B vitamins for 2 years. They had volumetric MRI scans and a cognitive battery at the beginning and the end of the trial. The primary research question was to look at the rate of brain atrophy, but they also had pre-specified secondary outcomes looking at cognitive function and other clinical changes. So this is the matrix that they put forward, that B vitamin treatment would impact homocysteine, which we know, that's a no-brainer, no pun intended. It lowers the homocysteine by 32%. Does B vitamins change the rate of brain shrinkage? And indeed it did. In intention to treat analysis, it lowered brain shrinkage by 30% per year in these two groups. So 30% sounds like a big number, but it's like going from 1.5 to 0.5. But this is clinically relevant. So they saw a significant main effect for B vitamin treatment in brain atrophy. They also wanted to look at the impact of whether or not people with elevated homocysteine had a differential response. And indeed they did. So the placebo group is in green, and this is quartiles of homocysteine at the baseline of the trial, and you can see that the rate of brain atrophy increases with increasing quartiles. But for those who receive B vitamins, you can see a much slower rate of atrophy in that 3rd and 4th quartile. So confirming that there was interaction with homocysteine and brain atrophy. So here's the MRI scans, and I'm not a neurologist, but what I do know is that the areas that light up in blue are what we're looking at here. So this is the placebo group, who had an average rate of atrophy per year of 2.5%. Their homocysteines increased from 22 to 30. When we look at those people in the B vitamin group, the atrophy was 0.4% per year, and homocysteine decreased from 24 to 12. So in addition to lowering homocysteine, the B vitamins did slow the rate of brain atrophy, and the next question in the matrix was, how would this impact cognition? So this is looking at the HVLT, the Hopkins Verbal Learning Fluency Test, where I would give you 12 words, and then I would give you a complicated task, and then 20 minutes later I would ask you what those 12 words were, and so how well you could recall those. So in people with their baseline homocysteine that was in the normal range, you can see those lines are very close together and no significant findings. But in people with elevated homocysteine at baseline, they preserved the ability to perform well on this task. They also looked at this by the clinical dementia rating, and so this is a scale that stages the severity of dementia symptoms, and so you want a score of 0 on this test because that indicates no dementia symptoms. So this is the percent of the group who had a 0 score for low baseline homocysteine. And when that was compared to high homocysteine at baseline, there was a significant increase in the percentage of the group that reverted to 0. So that B vitamin treatment in subjects with high homocysteine increased the proportion of people without signs of dementia by this rating. These are some other results that you can see from different types of cognitive function tests here. In the first set of tests, these are only significant for people with elevated homocysteine at baseline, but independent of baseline homocysteine, executive function was significantly improved in the B vitamin group. So indeed, finishing the matrix, cognitive decline was slowed. They were interested in also looking at what the effects of the B vitamin were on cognitive decline, because we know that in mild cognitive impairment in Alzheimer's disease, there are very specific regions of the brain that have shrinkage or atrophy. So, and similarly are related to cognitive function. So they used voxel-based morphometry to look at changes over time. And I wasn't really familiar with this, so just very briefly, this is a neuroimaging technique that will allow for observing changes in volume of the brain, okay? So what we're looking at here in yellow are areas that decreased in volume. And in the placebo group, there was a significant atrophy over 2 years in the medial temporal lobe. Comparing that to B vitamins, you can see that there's much less area of yellow lighting up here, indicating specific areas of the brain in which there was less loss. So this is looking at the same type. What we're looking at is the green highlights here, but this is looking at specifically the loss of gray matter and comparing the individuals with a normal baseline homocysteine to those with elevated. And I think it's easier to see if you look at the data this way, unless you're a neuroscientist, that those who had B vitamins had much less regional gray loss matter. Again, this was only seen in those people that had elevated homocysteine. So we know that there are specific regions that are related to these diseases. Were they picked up on this scan? And indeed, you can see here with the yellow asterisks, these are the regions that were significantly different between the B vitamin group and the placebo group, and those are the same areas that correspond with a number of the regions seen in Alzheimer's disease. So is it homocysteine? Is it folate? Is it B12? Because a lot of these trials combine them, it's really difficult to disentangle exactly which one of these it is. I will present just a little data from a systematic review looking at vitamin B12 independent of the other vitamins and homocysteine. So this was a systematic review of 6 prospective cohort studies and 2 randomized clinical trials looking at dietary intake or status biomarkers. The average follow-up was about 4 to 9 years, and the data come from just over 5,000 elderly subjects. Serum and plasma B12 was not associated with the risk of dementia, global cognition, or memory. And this is not necessarily surprising to me because we know that serum B12 is not a very good biomarker. It's the only one we have that's measured frequently, but it's not really the best. And what we recommended in a 2010 roundtable that we had at the NIH was that we would never look at B12, serum B12 in isolation, that we would want to look at it in combination with methylmalonic acid, homocysteine, or holotranscobalamin, which are much more specific indicators of B12 status. So there weren't as many trials with these type of more sensitive biomarkers. There were only 5 available, but of the 5, 4 indicated significant associations with the risk of dementia, Alzheimer's, and global cognition. So to summarize, I wish I could wrap this up in a nice, pretty package and give you an answer. I think that we've seen from all the talks this morning that it's not so simple. But what I can send you away with is that we know deficiency in either B12 or folate is related to increased risk of cognitive impairment and dementia. Elevated homocysteine is associated with a host of deleterious cognitive parameters in prospective studies. The meta-analysis of the randomized clinical trial data suggests that lowering homocysteine had no effects in participants with normal cognition. We went over some of the criticisms of that, but there are a large number of people in that trial, and so it certainly has to be taken into consideration when looking at the totality of the evidence. VITACOG provided some data to show that in older adults with mild cognitive impairment, intervening with B12, B6, and folate slowed the rate of brain atrophy, specific to regions that are associated with Alzheimer's disease. It slowed the rate of cognitive decline in several domains, and it improved the clinical dementia rating score. But this is only in people with high homocysteine. And so while this is a clinical trial, this isn't a clinical trial that randomized based on homocysteine. They randomized, and so this is sort of violating the principles of a clinical trial. So it's more or less a small cross-sectional study, but I think it's got very good data looking at neuroimaging techniques, and so I think that has sparked a lot of interest that we need to be looking at this question in different ways. So in conclusion, adding B vitamins in replete populations without cognitive impairment does not seem to confer any type of advantage. B vitamins in individuals with mild cognitive impairment may reduce brain atrophy and the rate of progression to Alzheimer's dementia. However, I think larger trials are needed in these vulnerable populations, and the data that I presented to you today were the populations with mild cognitive impairment and also the populations with elevated homocysteine, but there are also some data to suggest a differential effect of ApoE and depression in how B vitamins are processed and handled. So I would like to then end with a quote from Francis Collins that I think that as our technologies to understand the brain improve, I think we'll be able to address this question a little bit better than we have been able to thus far. So thank you for your time.